There are secret propeller mistakes wasting your horsepower right now, and you're probably doing at least 3 without knowing it. Every time you throttle up, you're throwing away 15 to 30% of your engine's power to completely avoidable mistakes that cost speed and burn fuel. However, the biggest secret isn't what you think. While everyone obsesses over pitch numbers, there's one invisible factor robbing huge RPM and significant speed without leaving visible clues. Happening to 80% of boats right now. Let's first expose the prop conspiracy that's fooling everyone. Let's start with something that's going to upset every prop shop in America. Blade shape matters far more than pitch numbers, and they've been selling you the wrong priorities for decades while making massive profits from your ignorance. Everyone gets mesmerized by pitch numbers. I need a 23-inch pitch for more speed. Here's what they're not telling you. A poorly shaped blade with perfect pitch will get destroyed by a well-designed blade that's 2 inches off the ideal pitch. The blade's cross-section, called the airfoil, determines how efficiently it converts rotation into thrust. Here's where it gets controversial. Those expensive racing props with radical blade shapes, they're often using NACA sections that were abandoned by aviation 30 years ago because better designs came along. But the marine industry was still using outdated technology and charging premium prices. The real secret is progressive blade design, where the airfoil section changes from hub to tip. Inner portions generate maximum thrust, while tips minimize drag and cavitation. A properly designed progressive blade delivers 8 to 12% more efficiency than constant section blades. But the biggest secret? Blade rake angle affects everything from acceleration to top speed. Most props use compromise rake that's optimized for manufacturing convenience, not your boat's performance. But wait until you hear what these tiny imperfections are secretly doing to your expensive horsepower and your wallet right now. Your blade's leading edge radius affects everything about performance. Too sharp creates cavitation inception at lower speeds, eating away at your prop before you even know it's happening. Too blunt creates excessive drag, robbing horsepower. Optimal radius is 0.5 to 0.8% of chord length, but most production props are nowhere near this because precision costs money. The difference between a $300 prop and a $1,500 prop often comes down to manufacturing tolerances that you can't see, but your engine definitely feels through reduced efficiency and increased fuel consumption. Most manufacturers use cheap, generic sections because developing proper hydrodynamic profiles costs serious money and engineering time. Progressive blade design requires each blade to be individually machined instead of stamped from a single die, tripling production costs. The aerospace industry moved to supercritical airfoils decades ago for better efficiency and cavitation resistance, but boat props are stuck in the 1950s because retooling is expensive. Forward rake gives better acceleration, but lower top speed. Aft rake provides better top speed, but sluggish acceleration. Most props use a compromise rake that's optimized for manufacturing convenience, not your specific boat's performance requirements. This technology exists and works, proven in aerospace and commercial marine applications, but almost nobody uses it. Now here's what those tiny nicks are really doing to rob you of serious horsepower and money. You think that little nick on your prop blade is cosmetic? Think again. I'm about to tell you why a ding smaller than a quarter can rob you of 200 RPM, and why that barely visible pitting is costing you thousands in performance. At 5,000 RPM, your prop tips are moving through the water at roughly 150 to 200 feet per second, depending on diameter. That innocent-looking nick creates a pressure disturbance that propagates across the entire blade surface. It's like throwing a rock in a calm pond. Those ripples spread everywhere. But instead of ripples, you're creating cavitation bubbles that collapse with the force of tiny grenades. Here's the physics that'll blow your mind. A nick just 1/8 inch deep, can reduce your prop's efficiency by 2 to 4%. That translates to losing 100 to 200 RPM at wide open throttle. On a typical setup, that's 1 to 3 miles per hour of top speed gone, plus 8 to 12% worse fuel economy because your engine is working harder to generate the same thrust. But nicks aren't the real enemy. It's that barely visible pitting that's killing your performance slowly and expensively. Want to know the critical difference between cavitation and ventilation that's confusing boat owners everywhere and quietly destroying expensive props? Cavitation erosion starts with microscopic bubbles you can't see. These form when water pressure drops below vapor pressure on the blade surface, creating tiny steam pockets. Each bubble collapse removes metal particles measured in microns, but after thousands of hours, you've got a prop that looks okay but performs like garbage. The industry secret? Most props start showing measurable performance degradation after just 100 hours of use. That's one season for many boaters, yet nobody talks about this gradual efficiency loss. Your prop doesn't suddenly fail. It slowly bleeds performance until you're burning 20% more fuel for 90% of the speed you used to get. Here's what's really controversial. Prop manufacturers could build cavitation-resistant props using specialized alloys and surface treatments. Military and commercial vessels use these technologies routinely. Nickel, aluminum, bronze, specialized coatings, even shot peening treatments that work harden the surface. But for recreational boats, they'd rather sell you a new prop every few years than engineer one that lasts 2 decades. The manufacturers love this because you blame your engine, your boat, or your driving instead of realizing you need a new prop. It's planned obsolescence through physics. Speaking of physics working against you, let me reveal the crew's RPM secret that's costing you hundreds in fuel. Every weekend, Warrior gets this wrong, and it's costing them thousands in unnecessary prop replacements. Let me clear this up once and for all, because understanding the difference could save your lower unit and your wallet from expensive mistakes. Cavitation happens when water pressure drops so low that it literally boils at ambient temperature. Your prop blades create areas of extremely low pressure, and when that pressure drops below water's vapor pressure, boom, instant steam bubbles. When these bubbles collapse, they release energy equivalent to small explosions. We're talking 15,000 psi concentrated on areas smaller than a pinhead. The physics get wild here. Water normally boils at 212 degrees Fahrenheit at sea level, but drop the pressure to 0.9 psi and it boils at 60 degrees Fahrenheit. Your prop blades can easily create pressure drops of 10 to 15 psi below ambient pressure, which means boiling water at any normal operating temperature. Ventilation is completely different. Atmospheric air getting sucked down to your prop usually happens when you're trimmed too high, turning too sharp, or running shallow where your lower unit sucks surface air. The prop spins in air bubbles, loses grip, the engine over-revs, and you lose forward motion. Dramatic? Yes. Damaging? Usually not. Here's what prop shops don't want you knowing. 90% of what they're calling cavitation damage is actually erosion that happened gradually over time, not from a single incident. Now let me tell you about the RPM secret that absolutely nobody discusses, but costs you massive efficiency every single trip. Here's the scary truth about cavitation that nobody explains. The damage follows predictable patterns that get worse over time, and most boat owners don't realize it's happening until they've lost thousands in performance. Cavitation damage is cumulative and accelerating. Each bubble collapse creates microscopic surface irregularities that become nucleation sites for more bubbles. It's like a cancer that spreads across your blade surface, getting worse over time until you're losing significant performance. The first 100 hours might show minimal damage, but hours 200 to 300 can see rapid deterioration. Salt water is actually less damaging than fresh water because the dissolved minerals change the bubble collapse dynamics. Cold water creates more violent cavitation than warm water. High-altitude boating creates cavitation at lower speeds because reduced atmospheric pressure lowers the cavitation inception point. The industry secret is that even the best props in perfect conditions will slowly erode over time. The question isn't whether it will happen, but how fast, and whether you'll recognize the symptoms before you've lost thousands of dollars in efficiency. Ventilation is usually your fault and fixable for free, but cavitation erosion is physics, and physics always wins eventually. Speaking of physics working against you, let me reveal the cruise RPM secret that's costing you hundreds in fuel. Here's something that's going to change how you think about prop selection forever. Everyone specs props for wide open throttle, but you spend 90% of your time at cruise RPM. And that's where most people are throwing away massive amounts of efficiency without realizing it. Your engine has a sweet spot for fuel efficiency, and it's not at WOT. For most outboards, optimal fuel consumption occurs around 3,800 to 4,200 RPM, which typically delivers 60 to 70% of maximum speed. But here's the problem. Most props are chosen to hit the engine manufacturer's recommended WOT RPM range of 5,500 to 6,000 RPM. This means your prop is completely wrong for the RPM where you actually spend your time. At cruise RPM, a prop optimized for WOT operates at terrible efficiency. It's like driving your car in first gear on the highway. It'll work, but you're wasting massive fuel and working your engine harder than necessary. A prop optimized for cruise efficiency might give up 2 to 3 miles per hour at the top end, but could improve your fuel economy by 20 to 30% at cruise speeds. That's the difference between 3 gallons per hour and 4 gallons per hour at your typical cruise speed. Here's the controversial part. Prop manufacturers know this, but they spec props for WOT performance because that's what sells boats. Nobody walks into a dealership asking about cruise efficiency at 4,200 RPM. They want to know the top speed, so that's how props get chosen. You're optimizing for a speed you rarely use while penalizing the speeds you use constantly. It's backwards economics driven by marketing psychology. The math is brutal. Let's say you cruise 80% of the time at 4,200 RPM and run WOT 10% of the time. A prop optimized for cruise could save you 1.5 gallons per hour at cruise, but cost you 3 miles per hour at WOT. Over a season, you're talking about hundreds of dollars in fuel savings versus bragging rights you rarely use. But those bragging rights sell boats, so that's what gets prioritized. Some manufacturers now offer cruise props, specifically designed for efficiency at part throttle settings. These props use different blade designs, pitch distributions, and sometimes different materials to optimize for the 3,500 to 4,500 RPM range where most boats spend their lives. But they're marketed quietly because admitting you need a special prop for efficiency implies the standard prop is inefficient. The technology exists for variable pitch props that automatically adjust for different operating conditions, constantly optimizing for whatever RPM you're running. These systems are used on aircraft and large commercial vessels routinely, but for recreational boats, cost and complexity make them impractical. So we're stuck choosing between speed and efficiency, and most people choose wrong because they don't understand the trade-off they're making. Speaking of choosing wrong, let me tell you about the blade count wars and exactly why more blades isn't always better. Time to destroy some sacred beliefs about propellers that are costing you performance and money. Everyone thinks more blades equals more performance, but that's not just wrong. It's expensive wrong that's been pushed by marketing departments for decades. 3-blade props are maximum efficiency machines when properly designed. Each blade operates in clean water with minimal interference from the others. The 120-degree spacing gives optimal thrust distribution and lowest possible drag for a given thrust level. But here's what they don't tell you. 3 blades also create the most vibration due to uneven pressure pulses, and they're more prone to ventilation in turns. 4-blade props spread the load more evenly but create more total friction because you've got 33% more blade area cutting through water. That extra blade area helps with acceleration and handling, but costs you 2 to 4% in top-end efficiency. The pressure pulses every 90 degrees make for smoother operation, but you're paying for that smoothness with speed and fuel economy. 5-blade props are where marketing takes over from engineering. Unless you're running extremely high horsepower or need maximum grip for water sports, 5 blades are usually overkill. You got 67% more blade area than a 3-blade, and drag increases exponentially with surface area. That extra blade only helps if your 3 or 4-blade prop is slipping. But here's where it gets really interesting. Contra-rotating props. 2 props spinning in opposite directions on the same shaft, eliminating torque effects and recovering the rotational energy that single props waste. The physics are beautiful. The rear prop operates in the accelerated water flow from the front prop, gaining efficiency while eliminating the spiral swirl that single props create. Contra-rotating systems can deliver 6 to 12% better acceleration and 3 to 6% better top speed compared to single props of equivalent total power. But they're also incredibly expensive, mechanically complex, and most manufacturers get the engineering wrong. The front and rear props need to be precisely matched, not just for pitch, but for blade angle, chord length, and rotational speed. The real controversy? Most contra-rotating systems on recreational boats aren't true contra-rotation at all. They're just dual props on the same shaft, both spinning the same direction. This gives some benefits from increased blade area, but none of the efficiency gains from eliminating rotational losses. True contra-rotation requires separate drive systems for each prop, which explains why it's so expensive. Want to know the biggest lie in the entire prop industry? The dangerous pitch myth that's costing everyone serious speed right now. This might be the most expensive myth in boating, and I'm about to prove why the prop industry's favorite sales pitch is complete nonsense that's costing you speed, money, and engine life while making dealers rich. Just add more pitch for more speed is the marine equivalent of just add more air to your tires for better gas mileage. It sounds logical until you understand the physics. Then it becomes obvious why it's wrong and why prop shops keep pushing this myth. They make the same profit margin selling you a 25-inch pitch prop as a 19-inch pitch prop, but they can charge more for the high-performance, larger number. Pitch doesn't create speed. RPM creates speed. Your prop's job is to let your engine reach its optimal RPM range while generating maximum thrust. More pitch loads your engine more heavily, reducing RPM. If adding pitch drops your engine below its power curve sweet spot, you've just made your boat slower, not faster. Here's the math that destroys this myth. Theoretical speed equals RPM times pitch divided by gear ratio and slip percentage. If adding 2 inches of pitch drops your RPM by 400, you haven't gained speed, you've lost it. A 21-inch pitch prop at 5,800 RPM will be faster than a 25-inch pitch prop at 5,200 RPM every single time. Ready for the one simple check that can reveal all these hidden losses? This straightforward test absolutely changes everything about props. But the real damage from overpitching isn't just lost speed, it's engine destruction that happens slowly, invisibly, and expensively. Running an engine below its designed RPM range under load creates excessive cylinder pressures, elevated exhaust gas temperatures, and accelerated bearing wear. You're literally cooking your engine from the inside while going slower. The opposite problem, underpitching, is almost as bad. Too little pitch lets your engine over-rev beyond its designed limits, reducing torque production and potentially causing valve float, bearing damage, or catastrophic internal failure. Modern outboards have rev limiters, but sustained operation at the limiter builds heat and stress. Here's what's controversial. Prop shops make higher margins on higher pitch props because they cost the same to manufacture but sell for more money. A 27-inch pitch prop costs no more to produce than a 19-inch pitch prop, but customers pay premium prices because bigger numbers seem better. The parts cost is identical, but the perceived value is higher, leading to bigger markups and higher profits. The optimal pitch puts your engine at 95 to 98% of maximum rated RPM at WOT with your typical load. Not 85%, not 105%, but in that narrow sweet spot where your engine produces maximum power efficiently without stress or damage. Now here's the simple test that reveals whether you're throwing away thousands in hidden performance losses right now. Here's the simple test that can instantly reveal whether your prop is costing you thousands in hidden performance losses, and you can do it on your next trip without any special tools or expensive equipment. This test has saved boaters millions in unnecessary prop purchases and engine repairs. The test is brutally simple. Document your RPM and speed at 3 specific throttle positions: 75% throttle, 90% throttle, and wide open throttle. Use GPS for speed, not your speedometer, because boat speedometers can be off by 15% or more due to pickup location, calibration errors, or simple age-related drift. Do this with your normal cruising load on a calm day. Here's what you're looking for. If your RPM only increases 200 to 300 between 75% and 90% throttle, your prop is loading your engine too heavily. You're in the flat part of your engine's power curve, where adding throttle doesn't add much power because you're fighting excessive pitch. Second red flag: if your speed gain from 90% to 100% throttle is less than 3 miles per hour, your engine is struggling against your prop instead of working with it. A properly matched prop should show steady, progressive speed gains all the way to WOT. But here's the advanced analysis that separates pros from weekend warriors. The slip calculation that reveals everything about your setup. Here's the calculation that reveals everything. Theoretical speed equals RPM times pitch times 60 divided by gear ratio times 1056. Compare that to your actual GPS speed. The difference is your slip percentage, and it tells you everything about your prop's efficiency and your engine's health. But here's what's crucial. This isn't just one number. You need to calculate slip at all 3 throttle positions. Optimal slip varies by application. Displacement hulls, 15 to 25%. Planing hulls, 10 to 20%. High-performance boats, 8 to 15%. Less than 8% usually means too much pitch. You're approaching the stall point where your prop loses efficiency rapidly. More than 25% means insufficient blade area, cavitation problems, or serious setup issues. But here's the advanced part. Your slip percentage should decrease slightly as throttle increases. If it increases dramatically at higher RPM, you've got cavitation or ventilation issues. If it stays constant across all throttle positions, your prop is well matched, but might not be optimized for your primary usage pattern. The most revealing test? Load your boat with your heaviest typical load and run the test again. If your numbers change dramatically, you need a prop optimized for loaded conditions, not the empty boat dealers use for demonstrations. This simple test reveals more about your prop's efficiency than any shop analysis or manufacturer recommendation. It's objective data about how your specific combination performs in real conditions with real loads. Want more brutal honesty about marine performance secrets? Check out the link in the description for our deep dive into hull physics that explains why your expensive boat might be fighting itself. And if these propeller revelations opened your eyes to how much performance you might be leaving on the table, hit that subscribe button, because we're exposing marine industry secrets every week that could save you thousands while making your boat faster, more efficient, and more reliable. Ring the notification bell too, because next week we're revealing the electrical system mistakes that are slowly destroying your boat's electronics, and the simple fixes the manufacturers don't want you to know about.